Technologies such as high-performance wireless connectivity, positioning for automated guided vehicles, and autonomous moving robots, drones, and extended reality are gaining more and more importance for industries seeking higher operational efficiency and flexibility. Qualcomm Technologies is at the forefront of research and development in all these areas. I'm excited to show you how our live OTA testbed in San Diego has improved with new capabilities for the smart factory and the innovation platform we are setting up in Lannion, France, in strategic partnership with companies and universities for end-to-end research on 5G and 6G for new verticals.
We have added several new capabilities to our live over-the-air testbed for the smarter factory of the future. We started with the Open RAN framework for a disaggregated 5G radio access network or RAN with time-sensitive networking or TSN and coordinated multipoint transmissions or COM. While TSN offers microsecond level synchronization between network elements and devices, 5G COM provides the ultra-reliable wireless connectivity foundation, and these features combine to deliver deterministic latency, a key requirement for industrial connectivity. We added a RAN Intelligent Controller or RIC from the Open RAN framework, which promotes a broad connectivity ecosystem with standardized interfaces between network functions. Together, these network capabilities help industries build flexible, scalable, and intelligent 5G networks with high performance for industrial needs. For efficient, ultra-reliable wireless connectivity, we developed Intelligent COM as a RIC application using machine learning to dynamically customize radio unit clusters for each 5G device. The radio units are clustered independently in the uplink and downlink to account for differences in the power levels between G node B and devices. To test Intelligent COM over the air in a dynamic wireless environment, we mounted a 5G device on an automated guided vehicle or AGV moving around our testbed over a long duration. Our results showed Intelligent COM significantly increasing air interface capacity without compromising the 99.9999% reliability target to be able to drive mission-critical applications on many more 5G devices. To test Intelligent COM at a larger scale, we simulated multiple scenarios in a factory setting with 18 radio units and randomized signal blockers. The simulation showed major savings in air interface resources. We also enhanced our 5G side link setup with dynamic path switching, which we tested with another AGV as a RF blocker in the over-the-head testbed. Since we prioritize the 5G side link for device-to-device communications, any packets lost over a degraded or obstructed side link are retransmitted over the air interface between the device and the radio units, also known as the UU interface with COM for robustness. With dynamic path switching, we further increase the air interface capacity while maintaining 99.9999% reliability. In conclusion, we demonstrated the smart use of wireless resources with technologies like Intelligent COM implemented as a RIC application in a disaggregated RAN with TSN and 5G side link with dynamic path switching without compromising on 6/9 reliability, all for higher 5G capacity and performance so industries can do more with 5G.
Hi, I'm Amira Aloum here at the Qualcomm Research Center in Lannion, France, where we advance long-term 5G, 6G research spanning systems design, standardization, and prototyping. We are setting up an innovation platform for end-to-end research on new verticals, including private networks, extended reality, industrial IoT, drones, and mission-critical applications. Our innovation platform is continuously upgraded to track standards and is a part of a strategic partnership with companies and universities in France on 5G and 6G solutions. Our innovation platform includes an advanced prototype radio access network that provides 5G millimeter wave to deliver low latency, high-speed wireless connectivity. It is highly flexible, can be upgraded with advanced 5G 6G features, and enables customization to address new use cases. The innovation platform includes state-of-the-art device reference platforms such as the Qualcomm Mobile Test Platform with the latest 5G features and XR headsets with additional on-device processing such as perception, tracking, video decode, and reprojection. The innovation platform also includes the Edge Cloud Server, which can host low latency, computationally demanding applications. We now demonstrate our 5G system level optimizations on the innovation platform for low latency, high throughput applications. As can be seen in the graphical user interface, the Qualcomm 5G system can support a consistent throughput of over 100 megabits per second, with an average 5G round-trip time of less than 15 milliseconds. This enables us to support applications like boundless XR. Our next steps include demonstrating over-the-air multi-user applications. We will expand the innovation platform to include indoor and outdoor sub-6 GHz and millimeter wave networks with multiple cells and multiple users. We look forward to working with our France partners on advanced 5G 6G use cases.